Welcome back. Here we have what looks like basically the exact same vessel that we used to fly to the moon. However, if you'll notice right here, it says a Minmus lander, because we are taking this to our other neighbor. Now, the way that I'm going to fly this is I'm going to try to avoid doing a plane change maneuver to the best of my ability. And the way I'm going to do that is you can see here I've lined up the orbit as best as I can with the equator. And I'm going to wait until our launch site is directly underneath the plane of Minmus's orbit. So just warping ahead here until about now. And so this does mean we are launching in the night. That doesn't really matter because the sun will be coming up in a few momentarily, and we will be launching directly into it. So without any further wait, we have Kimby here in the pilot's seat. 3, 2, 1, lift off. So for this one, I'm not going to bother trying to fly it all the way in high beam mode so that we can actually appreciate this vehicle from the outside and how this thing really flies. I do love the way those engines kind of taper off at the bottom there. It's reminiscent of the Delta IV heavy. Although these two on the outside are the Reliant, and the inside one is a KW rocketry engine, which has thrust vector gimbal control. So, we're just going to fly standard approach. However, we are going to be going into more of an inclined orbit. So you can see here we have our descending and ascending nodes here. And now, based on the direction that Minmus is traveling in, I want to go a bit to the south. So when I start my gravity turn, I'm going to aim for about 100 degrees heading, as you can see on the nav wall there. And I think I'm actually going a little bit too steep. So I'm just going to start to pitch over there. So now we're in orbit. What we've brought with us on this mission is a new bit of science. We have here the EVA science experiment. So we gotta get a little bit away from here. And now we can perform our EVA science. So This is a new bit of experimental data that we've unlocked. Just a bit more science that we can get from the different places that we visit. Watching the astronaut look through the EVA kit has given us conclusive evidence that it has not improved their creativity. Spinning the flange has led to an interesting and unexpected effect, the Janibekov effect. I do not speak Russian, so I probably pronounced that wrong. More surprising is that it seems to be still operating nominally while missing this part. Well, that is a pretty large flange there. Not sure where that would have fit. But yeah, that is a fascinating bit of rotational physics there. It has to do with moments of inertia and them not being aligned properly, or different modes of stability. And it does actually have some influence on spacecraft design. If you look, there are some spacecraft that have long solar panels that stick out in 3 ways. You don't really see any with 2, and that's because of that same effect, where if you had 2 solar panels, then it could make, when they spin stabilize it to make it hold its orientation. It can lead to the spacecraft flipping around and pointing the other way, which is bad for if you want to, say, point at the sun. And we have arrived. So now, naturally, we have a whole bunch of new science that we can start doing. So firstly, I'm going to do all of our major experiments. So there's materials study. High radiation environment caused a few of the samples to glow. It looks like it'd be fun to paint the rocket with this. Where's my barometer? There's my barometer. It reads 0. Mystery goo. What do you say? Feels right at home here. Thermometer. Temperature is impossible to measure out here. Yes, beautiful. Give me all that data. And now for our crew report. The lake beds seem relatively flat. Perhaps we could land there. Indeed, we most likely will. Although calling them lake beds is pretty interesting, seeing as Minmus is supposed to be mostly ice. It looks so small and yet so delicious. Well, it would take up a good chunk of the sky, although there is just a tiny bit of a crescent there. And we'll do the EVA science. All of this stuff. Kimby is, in fact, a pilot. So, all the same. So yeah, just realizing now that Kimby is a pilot, which means we can't actually have the mystery goo or the what's it called? Materials bay. Because if we took the data, we would not be able to restore them. Because Kimby is not a scientist. A slight oversight, but we will definitely be sending more missions here in the future. So we're just going to have to save these for the actual landing. Reset. Reset. And there we go. So now the plan is... So this is a bit low for a periapsis. That's about 5 kilometers is about as high as the highest mountains, and I want to have some distance between that. So I'm probably going to go for about, 10 is a good distance. Now, Minmus is very small. It's its radius 60 kilometers across. So like a large city, maybe the size of a neutron star. Everything in KSP is much smaller than it would actually be compared to real life. The diameter of Kerbin, or is this the radius? No, the radius of Kerbin is 600 kilometers, whereas the radius of Earth is 6,000. So there's a bit of a difference there. It's about, the distances are about 10 times scaled. So now we're just falling down to the moon of Minmus. We can see it there looming. And now there goes the camera switch. Let's get pointed for our burn. So this will just be for orbital insertion. And I think we'll have enough delta V that we could probably land on this transfer stage. I have basically unmodified. It's basically the exact same craft as we did for the moon landing, except with just some more life support on there, because this is a very long mission. We've been in space for 9 days. So now I'm just going to go ahead and insert ourselves into orbit. Still on an escape trajectory, and capture. Mostly circular orbit is really what I'm going for. I want to point this way. I'm being very perfectionist here. There's really no reason for me to be doing all this, but we have tons of fuel on this thing. I could probably land in every single biome with this, except I don't have the science abilities for that. So we're just going to call that our orbit. And admire the view. So now that we are low over Minmus, we have some more science that we can do. Of course, we are still limited in our options of what we can actually record here, since we're saving those 2 big experiments for our landing. Minmus is cold, ice cream is cold. Coincidence? You hope not. Well, if Minmus was made of ice cream, then that would imply that there are cows, or... Oh, I still have this crew report. Let's transmit that back. Take the new one. Wonder if Minmus tastes of mint, and if you could make a fortune selling tiny edible planets. Well, I hate to break it to you, but Minmus is in fact a moon and not a planet. So EVA report, aquamarine flats make you forget to keep one hand on the ship's handle at all times. Who cares about that rule? Not me. Let's do some EVA science. And same old. Yep. We're missing lots of flanges on this thing now. Hopefully that was not necessary. I'm sure the engineering and design bureau is going to, be monitoring the telemetry and making sure that all their systems are working perfectly. So now what I want to do is preferably I would want to land on a flat, and also during the day. So I think I'm going to come down on this big area here, except I want to wait until it is lit by the sun. So probably for just one more orbit. What's our orbital period? 46 minutes. So 10 minutes longer than a Kerbin orbit. And now we're going to start our descent. So because we are in a very wide orbit, I can afford to come down a little more steeply and a little more aggressively. I have delta V to spare. So I'm going to just go like that. Put ourselves very nearly suborbital, and in fact it's a collision course with these, with those mountains on the other side of the flat. And we're just going to warp ahead. So now I don't want to hit these hills over here. So I'm going to point retrograde, but also upwards. So that way I kind of slow down, but I flatten my trajectory and kill my vertical speed that I'm picking up from this descent. Okay, overdid the turn there. So now we are suborbital. But now you can see, I'm kind of lifting my trajectory. So that way I'm going to fall a little more steeply. And we're just going to go on ahead. There comes the sun. And we're coming pretty close over these mountains, but I think if I hadn't lifted my course like that, I would have probably come right onto those. And speaking of which, we might be hitting this mountain. So I'm going to actually go the other way. I'm going to burn this way. And I think that should be good. Yeah, whizzing by just a few hundred meters. We could practically touch those rocks there. And yeah, there's the flats. So now we can really start getting into our burn, our descent. And there's so much fuel in this stage. I think what I'm going to do is I'm going to try to put it down on the ground and then take off and land next to it. And we'll see. I want to get this transfer stage down in one piece. If I can land it upright, that would be even funnier. So that's what the goal is going to be. Flying this very carefully, of course. This is just like how they do it at NASA. Is they purposefully overbuild their vehicles and then land their stages on their engines and then land next to it. With fuel inside still. And in fact, I'm a little impatient, so I'm going to just start going, killing my horizontal speed now, and that way I can fall down a little bit quicker. 2 kilometers up. It's good that I'm actually landing in the morning, because then I can actually see some of the texture a little bit better and have a nice... Yeah, there's my shadow. So this will make landing a lot easier when I can actually kind of see the features and details that I'm coming down onto. Which is what they did for the other landings, of course, when they had humans on them. That's not what I did when I landed on the moon, though, which ended up being a little bit difficult, but this will hopefully go better than that. I think I could have done with getting rid of these tanks here. So now we're coming basically straight down. In my experience, these engines, you can land just fine on the engine bells, which is generally not ideal. You don't want to do that when you're actually flying something, because the engine bell is very delicate, and if you land on it and put the weight of a spacecraft on top of it, it tends to stop working as well. But these things can handle impacts above, I think, below about 3 meters per second, and they're generally fine. So now, going a little fast, but I think we've got it. Might kill this horizontal speed. There we go. So now... Nope. Okay. The upper stage failed to deploy, so we're just going to have to try again. Down nice and slow. And 1 meter per second. And there we go. We tipping? I don't think we are. There we go. So now, I want to land next to this, or on top of this thing again. So I'm going to point a little bit this way. And now we're going sideways. So, now we just land again. And this time we're going to go nice and slowly. Look at that view. Kerbin, the moon. And a little fast. Easy does it. And we are landed. Kimby Kerbin on her first flight, and she has landed 2 vehicles right next to each other. So we're going to let this thing balance out. And now, let's transmit that back so we can take more science. Crew report. The ground here is completely flat. It's really boring. Well, yeah, honestly, it's like Kansas. I can see that. But we have a monolith there, a marker of this moment. I really love how it's just standing there. I'm not going to try to go near it, because I think if I did, it would fall over. But now it's time for our real science. Instrument reads 0. It's a vacuum. What does the goo say? The goo starts to bounce slowly from top to bottom. Yes, because we just jiggled it around on our landing. Mrs. Gold, ice cream is cold. Well, we're going to get out there and check. And I believe we've invented surface samples at this point. So, conduct material study. What does it say? Bacterial samples appear to gorge themselves on what look like microscopic mint scones. Fascinating. Kimby, get out there and find these scones. For research purposes, of course. She has landed. The first footsteps. Let's see what she says. You order the engineers to start building a wicked fast rover to race on the flats at once. That would be fun, except the problem is above about 200 meters per second and your rovers will start to turn into flying machines because the curvature is so significant here and the orbital speed is so low that you can't really go above a couple hundred meters per second before you start to just kind of leave the ground. Take a surface sample. Glad of your geology classes, you search for rocks to analyze. Finding none, you curse bitterly. Bitterly? Is that how the samples tasted? Let's plant a flag. Yes. Admire the view. What shall we call this site? The first dual landing. Here, Kimby, Kerbin, hello, where's my cursor? Was here. Historic words that will go down in the textbooks. Yes, let's take a moment to admire this vista we've found ourselves in. Take your screenshots. Okay, with that out of the way, let's do the EVA science. We've got some golf. There it goes. Goodbye. The ball arcs off into the distance. You observe the ballet of physics. Based on how fast it looked like it was going, I don't think that's going to be coming down at all. Ever again. Why don't we check out this fascinating feature we've put here. I hope this thing stays once I, save and reload, because it's been a problem I've had where the debris just keeps deleting itself for some reason. Yes, let's stand next to it. Really appreciate just how large some of these vehicles can be. Come on. Turn around. Smile for the camera. Wow, that really puts things into perspective, doesn't it? Yeah, that's a nice postcard picture right there. And I think that's enough of Minmus. Let's see how high we could jump. Oh, we could totally jump into this thing right here. Except I'm not going to try to land because I don't want to tip it over. It would ruin all of our hard work. So now we just have to take all of the experiments back into the capsule. Oh, let's not hit the antenna. Come on. Get in there. Collect data. Where's my mystery goo? Collect data. My barometer. Take that data. And my thermometer. Take that data. So now that we've taken all of our data, it's time to actually go somewhere with it.